Hi there, welcome back. If you've watched any of the tube radio restoration videos on my channel, you'll know that I like to add Bluetooth reception to them. Now, I install the Bluetooth modules as unobtrusively as possible so that it doesn't detract from the value of the set, and it's also completely reversible so I don't get blasted by the purists out there. Full respect. Now, these modules are very easily and cheaply available all over the net. They come in various shapes and sizes, and what I need to do every time I build one is to build the power supply section with an isolated power supply so as not to get buzz going into the system. If you've tried to install one of these directly into your radio, you'll know that you can actually hear the buzzing that the digital circuitry causes, and that's very, very annoying. It takes away from the quality of the audio, and so you need to isolate the power supply and the audio grounds in order to avoid that. The problem with this is that every time I install one, I have to build a power supply board, and I've done this using some proto board, and it's quite simple but quite annoying because it is repetitive. And I decided it was time to design and build a PC board, order a few of them, and have this lying around for whenever I need it. And fortunately, as I've recently discovered, there is a very simple way of doing this. And I'm going to go through the whole procedure here where I build the base board, the supply board, for the module to be incorporated in it. And I'm going to make that as adaptable as possible so that a variety of different modules can be used. And the whole thing becomes simpler, quicker, and certainly with better quality in the final result. Let's get started. Before we go any further, I think it's become obvious that this is the solution I'm talking about. These guys are called JLCPCB, and I started using them some time back, and I really was very, very happy with the results. And I became even happier when they contacted me and asked me to promote them, which I do gladly. And I do stand by what I am saying here. This is not just because it's a promotion. I've actually done a video prior to this one where I show you the quality of these PCBs, which is really what turned me onto them. However, I want to show you something else, and I want to show you the ease with which these boards can be made and ordered. And I have to tell you, this is the first time I'm using this solution because in the past I've used Eagle, which you'll probably know there's a bit of a learning curve there, but once you know it, it's there. However, I decided to go into a new learning curve, and that is by using the resources, one of the resources that they offer, which is EasyEDA. Now, if you click on there, you get the EasyEDA website, which you can download and then start using. As I said, this was a bit of a learning curve. I'm still on it. But I want to go ahead and design that schematic that I showed you there on EasyEDA, and we'll do this together and actually do the order for the PCBs so you get an idea of exactly what this entails. So let's get going. Once you open the EasyEDA app, this is your start page, and I'm going to start by creating a new project. I'll call it Bluetooth board. And then on the project itself, I'm going to create a new schematic. And there's our schematic. Now, the first thing I'm going to do is populate this with the components I need for that circuit. Now, the circuit is a very simple supply. It's obtaining power from the 6.3 volts heater line, AC, rectify it, smooth it, feed that the result into a LM7805 voltage regulator, smooth that out again, and then feed that to a voltage isolator, DC to DC converter, 5 volt in to 5 volt out converter, which will produce an isolated DC voltage at the output equivalent to the one at the input, and that's the one I'm going to use to power the board. So the first thing we're going to do is find the components, and you can do that in various ways. The first one would be this library, this EE library, which gives you most of the common components. And if you choose components here, you can actually see what they are. You get female headers, 2.54, 1 times 4. I want a 1 times 2, but I'd rather use a male header, 1 times 2, so we'll put that in here. We then need a bridge rectifier. I think this is the one I want. I want the small one. Anyway, I'll put it in and we'll see. Now, capacitors, for example, the electrolytic capacitor filter cap, if I go on here, it just gives me some sizes. Now, what I can do here is I can actually go and find specific capacitors by choosing one of the libraries here. And I can choose the LCSC Electronics library. And the LCSC is actually part of JLCPCB. They're an online component store with a huge, huge stock of components. And you can search for the components very much like you would in any electronic store. So I'm looking for a Nichicon 1000 microfarad, and I can choose some sizes. Let's choose that one. That looks about right. That's the UPM, UHW. Now, depending on what you're more accustomed to, you can choose whichever one you want. I'm going to choose this one. And I can place that there. I'll need a 100 microfarad one later on. So the advantage here is you actually search for them very much like you'd search for components on a store. And you can actually find the specific component that you want. That one there, you can search further and you see the whole order page, but we don't really need that at the moment. So I'll place that guy. And now I'm going to do the same for all the other parts. But specifically, I want to show you that this one here, this is a very strange component. The B0505S is that 5 volts to 5 volts, 1 watt DC to DC converter. Now I can actually put in the model number up here and I can see what it looks like. This is the one I want and I can place it. Now I very much doubt that you'll find some of these components on Eagle. And the advantage is that here you have access to part numbers, specific model numbers, specific suppliers, and everything like that. So what I'm going to do is I'm going to just quickly find all the components we need, and then I'll get back to you. Right, here we have it. This is the full schematic. I have tried to choose the components very specifically to the ones I want. I believe I have everything here. Something I may not have mentioned is that these little boards, they're stereo boards, so they all have left, right, and ground output. Most of my radios use mono. So what we'll have here is we'll have two 1K resistors that'll link up here to create the mono signal. Actually, I'm going to change that. I'm going to leave that optional because if I do want a stereo, I don't really need to do anything, do I? I can just use it there. So now we've got the schematic sorted. We save it. I believe that's saved. And now we need to do the PCB. And up here, where is it? Here. This function lets you convert to PCB. So we'll just click it and see what happens. And here we have our PCB setup. So units, millimeters, yes. Copper layer, 2 layers, board, rectangular. I think we can sort out the size later. I'll just say yes. And we have all our components here. Well, this looks familiar. This looks very familiar. So now you just start laying this out on the board any way you want. Okay, I'm going to sort that out. I'm going to set this up, the layout, the way I want it. and come right back. Right folks, we're back. And I think I've now got a routing that I'm happy with. I think I may still change something. In fact, I will. This here, I'm going to make it a connector, a header, like that one. So let me go back and do that. So here we have it, finally. And I say finally because I'm a faffer when it comes to laying these things out. I go to incredibly, stupidly meticulous detail, and I tend to change my mind a lot. But anyway, I've now got the components laid out the way I like them. I have adjusted and corrected and repositioned the actual labels, component identifiers, exactly the way I like them. I have created in this section here, over here, positioning of the pins to correspond exactly with the pins on the board that I'm going to use. So this is what fits on that board. However, I'm not sure how long I'll be using that board for, but I've got 10 of them that just arrived, so I expect that for now I'll be using at least 10 of them. So it doesn't mean I can't use this board with something else. I can, because I've got the supply here, ground and the positive supply. This V plus is actually going to be 4.3 or 4.4 volts, because coming out of this DC to DC converter, I have a diode in place which drops 0.6 or 0.7 volts. Then it goes through a smoothing capacitor, and then another, just a small value filter capacitor, and that is giving me the plus 5 volt minus the diode drop, which then supplies the board. Now I know this board actually has 3 pins. One is ground, 0 volts. The other one is actually 5 volts, and the other one is V plus battery voltage. Now what they do in here is they do exactly what I've done here. They take the 5 volt one and they pass it through a diode, and that gives them the battery voltage. The only thing I don't like about it is that there is no filter capacitor after the diode. So what I've done here is I've basically bypassed the internal diode, and I've got my filter capacitor here. These particular DC to DC converters suggest you don't go over 220 microfarads as the filtering. I've got 100, should be more than enough. This little board I've checked draws about 30 milliamps, so we're not dealing with major current draws here. And I'm hoping that'll be sufficient and that this thing will be as quiet as a mouse. Now, what can I do now? I've got this thing done, and this particular software has got some really neat features. Let me show you. You can do a photo view, and the photo view gives you, as the name implies, a photographic view of what it is you're going to order. And in this particular case, I'm seeing the top layer. And if I go to, let me just get rid of the grid. Okay. If I do the bottom layer, this is what I'm going to see. And it's going to be exactly like that. And I think that's great. You can actually check it, make sure it's the way you want it, put some text in there. And the other thing I can do is I can change the board color, and it'll give me a simulation of the board color. Let's try, there's a funny one here, copper. I like that, but I'm not sure I'm brave enough to order that just yet. I think I'm going to probably go for the blue. I like the blue. The black would be neat as well. Of course, you can't see the black on here because it's got a black background, but I can change that to a white background, and that's our black. Now, the other thing I can do, let me switch off this photo view. If I go to the board, I can do 3D view. Oh, please try again after saving the file. They do want you to save the file, because this thing is done via cloud. So, 3D view, what does that give us? Cool. That is cool. That is literally a 3D view of the two sides. Fantastic. Now, can I change that as well to black? Yes, I can. Let me make the background white again. And this thing looks really, really neat. And it'll probably, black is probably going to be the color I choose. Of course, the advantage with the JLCPCB website is you can choose any color or a lot of colors. And the advantage here is that all the features that you can order are given to you as options for the viewing. So you can actually see specific, well, let me go to blue just to make it easier. You can actually see specific things, like for example, if I want the top silk layer to be invisible, I can make it invisible. If I want the solder mask to be invisible, I can make it invisible. So I can actually check every single thing here, which I think is pretty cool. Now I know there are quite a few other software packages that probably do this or better. But as I said, I stick to old habits, and I got into the habit of using Eagle. And on Eagle, I've never tried this. I'm not even sure it does this. But anyway, that's our PCB. Except I believe I'm going to order it in black. Voila. And now we come to the final bit, which is to actually create the Gerber files. So how do you go about it? Well, let's find out. I saw this up here that says generate fabrication file Gerber. So let's click on it. Would you like to check the DRC before generating? Yeah, let's see what's wrong with it. I don't think there's anything wrong with it, which is brilliant. So let's generate Gerber. And bloody hell, this is already giving me the order stuff. Thickness, let's see, PCB color, black. Surface finish, that's all with leads, with lead. Copper weight. Price $5. If I'd made that $5, it's $2. This is amazing. This is amazing stuff. I mean, $2 is what I pay for the bloody muriatic acid that I used to etch one of my homemade boards. I mean, I'm gobsmacked. I think I'm just going to do 10. Yep, gone up because the shipping will probably be the same. And I order at JLCPCB. Let's see if this works. Order. So here's our order sheet. Now I have chosen purposely 10 units. Gives me my $5, which is €4.48. 3 to 4 days production time. And I'm going to say that the shipping is €5.22, which I expect anyway for Portugal. Save to cart. And if I go to cart, I still want to order some parts, but if I want to go to cart now, this is my final order. Order total, something is wrong here. Oh, okay. This was the previous order that I made. It's getting confused here. And I want to check out securely. Yes, securely would be good. I think I've got everything. Well, you know how it goes from here. I don't want to get into my personal details. And the whole thing is done from within here, which is brilliant. So this particular software, what are the advantages? What can I say about it? Well, it took me one evening, quite a late evening, to become comfortable with it, as comfortable as I need to be to produce the results that I've produced. There's still a hell of a lot to do and a hell of a lot to learn, I'm sure. But I can now actually use this quite comfortably. And so the learning curve, although there is one, it's nothing major, it's nothing too dramatic. So I'm very happy with that. The other thing that I'm really happy with is I can actually search for very specific components from the actual supplier that's associated with JLCPCB, where I can order them or select them before placing them on the board or on the schematic by their full characteristics. So I can choose size, I can choose diameter, I can choose the pin spacing, I can choose the height, I can choose the wattage. I can go there and select it with the filtering that they have, exactly the same as I would do when I'm ordering it from an online supplier. And the fact that this is an online supplier just makes it easier, because I get to the end and I click BOM and I've got my BOM, my bill of materials, which I can then export as well, or print, or check out, go to the order, and it'll tell me the prices of everything. And this is fantastic for something as simple as this. So, in summary, I am extremely happy that I made this move to try out this software. I was already happy with the quality of the PCBs that I got. So this is phase 2. And when I get these PCBs, I'll do another video and show you what the result is like, and onwards. I want to thank you all for your patience, for watching, if you've lasted this long. And I hope to see you again very soon. Thanks for watching. Bye for now.